While everyone has been busy comparing lap times from Bahrain testing, Ferrari quietly bolted something onto the back of the SF26 that sent engineers from rival teams scrambling for their cameras. It's a small aerodynamic wing mounted directly in front of the exhaust outlet at the rear of the car. The paddock is calling it the FTM device, and no other team can copy it without redesigning their car from scratch. But that's not even the biggest story. Ferrari is the only team on the entire grid running steel alloy cylinder heads in their power unit. Every other manufacturer uses aluminum, and the reason Ferrari made that choice could give them a lasting advantage that no amount of aerodynamic development from Red Bull or Mercedes can touch. These are the kinds of details that don't show up in a lap time comparison chart, and they only make sense once you understand the decision that started all of it, a decision Fred Vasseur made in April of 2025 that even Ferrari's own fans are only now beginning to appreciate. In the spring of last year, Ferrari was still in the fight. The SF25 wasn't a great car, but it was in the mix. There were upgrades in the pipeline, and the championship battle was close enough that walking away felt like madness. But Vasseur did something that no Ferrari team principal in recent memory has had the nerve to do. He told his engineering department to stop developing the 2025 car entirely. Every wind tunnel session, every CFD simulation, every resource the team had redirected to a car that wouldn't turn a wheel for another 8 months. The consequences were immediate and painful. Ferrari finished 2025 without a race win. The Italian media was brutal, and when the final constructors' standings came in, the team had dropped to 4th place. But here's where it gets interesting. That 4th place finish actually handed Ferrari something valuable. Under Formula One's aerodynamic testing restrictions, teams that finish lower in the championship are allocated more wind tunnel and CFD time. Ferrari now has 15% more development hours than McLaren for the first half of 2026. So while it looked like Vasseur was surrendering, he was actually buying his engineers more time with the SF26 than any Ferrari development team has had in years. The man trusted to use that extra time is Loic Serra, Ferrari's new chassis technical director, who arrived from Mercedes in October 2024. Serra's fingerprints are all over this car, and the first thing he changed tells you everything about his philosophy. For years, Ferrari had run a pull-rod front suspension layout. Serra replaced it with pushrod geometry front and rear. That might sound like a minor technical footnote, but the implications are significant. Pushrod suspension positions the rockers, springs, and dampers higher up in the chassis, which cleans up the lower bodywork. And cleaner lower bodywork means more airflow reaching the floor, which is where the vast majority of downforce is generated on these cars. The front suspension also uses an extreme multi-link geometry with a pronounced anti-dive angle. What that does is prevent the nose from pitching forward under heavy braking, which matters even more now, because the energy recovery system under the new regulations is almost 3 times more aggressive than before. There's significantly more force going through the front axle, and Serra's design manages that without unsettling the car. It's working. Technical analyst Niels Wittig described the SF26 as transformed between day 1 and day 3 of Bahrain testing, with rear stability improving dramatically through setup evolution. Both drivers reported the car becoming progressively easier to push. But the suspension is just the foundation. The real conversation in the paddock right now is about what's happening inside the engine. Ferrari's 066/6 power unit involves a material choice that had rival engine departments raising their eyebrows from the moment it became known. Every Formula One engine since the turbo hybrid era began in 2014 has used aluminum alloy cylinder heads. It's lighter, well understood, and every manufacturer has decades of experience with it. Ferrari looked at the demands of the new fuel regulations, where cars must run on 100% sustainable fuel, and decided aluminum wasn't going to cut it. The combustion pressures and temperatures generated by sustainable fuel are significantly higher than those produced by conventional fuel. Aluminum begins to struggle at those extremes. So Ferrari partnered with AVL, an Austrian powertrain engineering firm, to develop steel alloy cylinder heads incorporating copper and ceramic elements. This has never been done before in Formula One. The weight penalty is minimal because the minimum power unit weight already increased by 30 kilograms under the new rules. And the benefit is that Ferrari can run higher combustion pressures than anyone else on the grid, which translates directly into greater thermal efficiency from the internal combustion engine. Here's why that matters for the entire season. Engines are homologated. Once racing begins, you cannot change the fundamental design. If Ferrari's steel cylinder heads give them a combustion efficiency edge, that advantage is locked in for the whole year. Red Bull can bring 10 floor upgrades between now and Abu Dhabi, and none of it will close a gap that exists inside the engine block. Ferrari also made a counterintuitive choice with their turbocharger that puzzled the paddock during testing. Mercedes, Red Bull, and the other manufacturers all opted for large turbines to maximize peak power from the internal combustion engine. Ferrari chose a deliberately smaller Honeywell unit. On paper, that sounds like leaving horsepower on the table. But the smaller turbine solves several problems at once. It spools up faster, meaningfully so on race starts when the car needs instant power delivery. It reduces dependency on the electrical motor during acceleration, which matters because battery management is going to be one of the defining challenges of this season. And it gives the drivers better, more predictable throttle response by reducing turbo lag. Charles Leclerc touched on this indirectly in his Bahrain debrief, describing the SF26 as very different from anything he's driven before and calling the new generation of cars genuinely interesting from a driving perspective. Lewis Hamilton was more direct. He said the car is a little oversteery and snappy, but easier to catch, and that it's more fun to drive than he expected. That phrase, easier to catch, is precisely what the smaller turbo strategy is designed to deliver. Now, the upgrade that has the entire paddock talking, the FTM device. During the second Bahrain test, Ferrari revealed a small aerodynamic wing positioned directly in front of the exhaust outlet at the rear of the car. To create space for it, the team had moved the differential as far rearward as physically possible within the allowable crash structure. According to technical analysis from motorsport.com, the entire rear end of the SF26 was designed from the very beginning to accommodate this device. That last detail is critical. This is not a bolt-on idea developed late in the design process. Ferrari planned the architecture of the car around the FTM device from day one. The gearbox layout, the suspension geometry, the packaging of the rear end, all of it was built with this feature in mind. And that creates a significant defensive barrier. If Mercedes or Red Bull see the data and want something similar, they cannot simply add it to their existing car. They would need to fundamentally redesign their rear-end packaging, months of work at minimum. By the time they could implement it, Ferrari would already be developing the next iteration. Ferrari is also reportedly holding back additional aerodynamic innovations for Melbourne, including a revised side pod configuration. They showed Bahrain what they wanted Bahrain to see, and nothing more. But talk is cheap in Formula One. Upgrades mean nothing if the stopwatch doesn't agree. So let's look at the data that actually matters. The headline lap times from Bahrain had Mercedes at the front. Kimi Antonelli posted a 1 minute and 33.669 seconds and George Russell a 1 minute and 33.918 seconds. Ferrari's best were Hamilton at 1 minute and 34.209 seconds and Leclerc at 1 minute and 34.273 seconds. If you stopped reading there, you'd conclude Mercedes was clearly quicker. But experienced paddock observers don't evaluate testing on single lap times. They look at race simulations, long runs designed to replicate actual Grand Prix conditions. And that's where the picture changes. On the evening of Day 3 in Bahrain, 3 teams ran simultaneous race simulations. Hamilton's Ferrari averaged 1 minute and 40.280 seconds on an opening stint on soft tires, then 1 minute and 38.929 seconds on hards, before finishing with a 1 minute and 37.461 seconds on mediums, at which point the team deliberately ran the fuel tank dry as part of a planned systems check. Mercedes was comparable across their stints. McLaren's Lando Norris, however, was consistently 0.7 to a full second per lap slower across all 3 stints. In pre-season testing, where every team is supposedly sandbagging, that is a significant gap. Ted Kravitz confirmed what the telemetry showed. Hamilton completed the fastest race simulation of anyone across the entire test. And McLaren team principal Andrea Stella publicly acknowledged that Ferrari and Mercedes are ahead of them on race pace. When a team principal says that on camera, the gap is real. The reliability data is equally telling. Ferrari's power unit accumulated roughly 4,300 kilometers without a single mechanical failure, the equivalent of 14 Grand Prix distances on one engine. The only stoppage during the entire test was Hamilton running the car dry deliberately, which Vasseur confirmed as a planned exercise. For context, Mercedes managed 282 laps due to suspension and power unit issues. Red Bull completed 343 laps before a hydraulic failure. Aston Martin reached just 206 laps with Honda engine difficulties. So is this another false dawn? Ferrari's track record with promising pre-seasons is genuinely painful. The 2022 car won 2 of the first 3 races before Red Bull outdeveloped them into irrelevance. The 2025 car was compromised before it even reached the grid. But the structural changes at Maranello this time are different in kind, not just degree. Sarah has replaced a siloed culture, where the engine and chassis departments barely communicated, with an integrated design philosophy. The SF20 SIXS power unit was built from the outset to give the aerodynamics team maximum freedom with the rear packaging. The car passed all FIA crash tests on the first submission, saving weeks of development time. And Vasseur has confirmed strong correlation between their wind tunnel, their CFD models, and the track data from Bahrain, a problem that has undermined Ferrari upgrade campaigns for years. Vasseur himself has been deliberately measured with the media. No predictions about race wins. No championship promises. His words after Bahrain were simple: stay quiet and focus. That is a very different Ferrari. The SF26 doesn't need to be the fastest car in Melbourne. It needs to be the most developable. And from everything we've seen across 4,500 kilometers of preseason testing, it might actually be both.